Ever wonder how AI is getting better at understanding videos, not just seeing what's happening, but figuring out what it all means? Like if a person is slicing an onion, does the AI know they're about to cry? Or if a chef is stirring a pot, can it predict when the sauce will thicken? That's the magic of multimodal large language models, systems that learn from text, images, and video to think smarter, not just store more data. Let's break it down. Traditional AI models struggle with videos because they're complex, lots of moving parts, timing, and context. But researchers are solving this with clever tricks. Take Vision-R1. It's like teaching a student to solve a puzzle by breaking it into steps. The model doesn't just guess the answer, it reasons through each part step by step. Then there's NoisyRollout, which throws tricky scenarios at the AI, like adding blur or weird angles to videos. It's like giving a pianist harder songs to master, forcing the model to adapt. But here's the real game changer, VL-Rethinker. This method lets the AI critique itself, like a student reviewing their work after an exam. It asks, did I get that right? What if I tried a different approach? By reflecting on its own guesses, the model becomes more reliable. The math behind it. It's all about balance. Researchers tweak a formula that weighs two goals, maximizing rewards like correct answers, while keeping the model from straying too far from what it already knows. Think of it as a student learning new facts without forgetting the basics. A key part of this is KL divergence, a fancy term for measuring how much the model's new strategy differs from the old. By controlling this, the AI learns efficiently without forgetting what it's mastered. What's the payoff? These techniques make AI better at tasks like video analysis. Imagine an AI that watches a cooking show and not only describes the steps, but also predicts why a recipe might fail. Or a medical AI that analyzes scans by cross-referencing textual reports and visual data. This is the future of video reasoning. But let's get specific. Traditional AI models trained on video face two major hurdles: training instability and vanishing advantage signals. Think of it like teaching a dog to fetch. If you're inconsistent with rewards, the dog gets confused. Similarly, video models struggle when feedback becomes too weak over time, making it hard to distinguish good decisions from bad. Enter Reg-GRPO, a breakthrough in reinforcement learning. Unlike older methods that compare groups of responses, like a teacher grading essays against each other, Reg-GRPO turns learning into a regression task. Imagine training a model to predict the value of a decision directly, like a student who studies past exams and guesses the next question. This eliminates the need for stabilizing crutches and keeps the learning signal strong. Here's the kicker. Reg-GRPO uses a difficulty-aware data augmentation strategy. It's like tailoring workouts to your skill level. The model gets training videos that are just hard enough to challenge it. No too easy, no too hard. This creates richer feedback, helping the AI learn faster and better. The results? Models like Deep Video-R1 smashed benchmarks in video reasoning tasks, outperforming previous methods by significant margins. This isn't just incremental progress, it's a paradigm shift. By combining direct prediction, adaptive training, and self-critique, we're building AI that doesn't just process data, but understands it. Hey everyone, welcome back. Today, we're diving into why the way AI learns is about to get a major upgrade, and why that matters for your tech, from smart assistants to life-saving medical tools. Let's start with the big question: why does AI learning matter? Imagine a virtual assistant that doesn't just follow commands, but understands context, like knowing when you're stressed and offering help. Or an AI that analyzes medical scans with the precision of a seasoned doctor. These aren't sci-fi dreams anymore. They're powered by algorithms that learn from experience. But here's the catch. Traditional AI systems often guess how to improve, which can lead to errors. Enter Reg-GRPO, a breakthrough in how machines learn. Think of it like teaching a robot to walk. Instead of just saying, "good job," when it stands, Reg-GRPO lets the robot predict what actions will work best, like a student who studies past exams and guesses the next question. This approach cuts down on mistakes and makes learning faster and more reliable. The math behind it. Let's simplify. Traditional methods estimate feedback, called an advantage function, indirectly, like trying to guess a teacher's exam questions. Reg-GRPO flips the script. It directly predicts that feedback, using a formula that minimizes errors. The result? Smoother, more accurate learning, especially in tricky real-world situations. But here's what's really exciting. This isn't just theory. Researchers tested Reg-GRPO in real scenarios and found it outperforms older methods. It's like giving AI a clearer roadmap, so it adapts faster and makes fewer wrong turns. And because they shared their code and data, other scientists can build on this work, accelerating progress for everyone. Of course, with great power comes great responsibility. The paper also highlights ethical considerations, ensuring AI doesn't harm users, protecting privacy, and being transparent about how systems work. It's not just about making smart AI, it's about making safe AI. So what's the takeaway? Reg-GRPO shows that small changes in how AI learns can lead to huge leaps in performance. It's a step towards systems that think, adapt, and act more like humans, without the headaches. Stay curious, stay informed, and don't forget to like and subscribe for more deep dives into the science shaping our future. Until next time, keep exploring.